Alright guys, so here's our video tutorial on crossing streams. So of course, crossing streams seems very straightforward, but we're going to look at in the physics eyes and doing vector diagrams. So it can be a little bit more complicated. So let's take a look at the problem that we're working on in class. Then I'll post another video of another example to help you guys out just to see it from a different perspective. Here's the problem we're working on. The boy is going to row north across the stream. That is 2 miles wide. The stream flows at 3 miles per hour east. If he rows and has a velocity of 4 miles per hour, what is his resultant velocity? Some things to be kind of wary of or kind of notice while you're doing these. This 2 miles, that's going to be a distance or a displacement. So that'll be a d, okay? Which means if I'm making a velocity triangle, things like this and this are velocities, I can't include this d. You can never do a triangle that has displacement or distance and velocity, okay? So whatever the triangle is, it has to be for that vector or that scalar. It cannot be a mix of two. So if we're looking for resultant velocity, keeping in mind that velocity is a vector, so it has magnitude, and it also has direction. Okay, so we need to find both of those components to answer this question. If it just said what is his overall speed, then we can just find the magnitude and carry on. But we need magnitude and direction. We need to solve for both of these components. So I'm just going to erase this to give myself some more room. First, let's deal with the magnitude portion. Tends to be a little bit more straightforward. It's just going to be using Pythagorean theorem. So I'm going to let red be him and, I don't know, green be the river, okay? So he is going to be going 4 meters per second, miles per hour, 4 miles per hour north, okay? So you can imagine the shore is here and here. He's going to be going 4 miles per hour across this lake or stream or whatever it is. And remember that north, east, south, and west, okay? We're going to have a push. So the stream is going to push him 3 miles per hour to the east, okay? So you can see already we have a triangle forming. This is a right angle because it's the right angle here, okay? All of the directions of north, south, east, and west are all going to meet at right angles, which is helpful. So what we're going to do to get the resultant velocity is use his the hypotenuse here, okay? So this will give us the resultant magnitude, okay? Magnitude. So in order to do that, we're just going to use Pythagorean theorem. So recall that Pythagorean theorem is c squared equals a squared plus b squared. So it doesn't matter which one of these two things you're going to use for a squared or b squared. So we're going to say c squared is equal to 3 squared plus 4 squared. And so c squared will equal 25. Oops, 25. Then to clear that up, I just take the square root. So c equals 5. Square root of 25 is 5. And that's in miles per hour. Okay? So I have 25 miles per hour is my new magnitude. That is my resultant velocity magnitude. Now remember, velocity has magnitude and direction. So we're headed there now. We're going to now look at the direction. So let me just copy this. And then I can erase some stuff here. All right. So we know that we're moving at 5 miles per hour. So he's moving at 5 miles per hour. But we don't know what direction yet, okay? So in order to figure out the direction, what we need to do is consider the angle he's traveling at. So you always start at the start point, okay? So he started here. He started going north, and he got pushed east, so we're looking for this angle in here. So I'm looking for that angle. I recommend you always use what they gave you when using SOHCAHTOA. Okay, so now we're going to use SOHCAHTOA. Always use what they gave you in case you made a mistake in calculation. So if I'm using what they gave me, if I'm trying to find this angle down here, this would be my opposite, this is my adjacent, and this is my hypotenuse. I'm going to use opposite and adjacent because that's stuff that they gave me, so I'm going to be using TOA. So tan of theta is equal to opposite over adjacent. Okay, and so what that equals, so then we put that in our calculator as tan -1, put it in brackets, 3 over 4 is equal to theta, and so theta should equal 37 degrees. Okay, so take a minute, confirm that that works for you. You can pause the video at any time. So, our final statement is going to be that his resultant velocity, now remember this has to have magnitude and direction, his resultant velocity is going to be 5 miles per hour, and he starts off north, and then he gets off course 37 degrees to the east. So that would be your resultant velocity. We have magnitude and direction. Okay, let's look at part B. Part B says, what is the actual distance he travels? So I want to recall this triangle is how he's traveling. Okay, we found that this angle in here is 37 degrees. But now we're looking at distance, so we don't want to really deal with those velocities anymore. So we start putting on our triangle things that relate to distance. So specifically, this 2 miles. I know that the distance from one shore, so here's one shore. I know that the distance from one shore to the other is 2 miles. Okay, so I have 2 miles here. And if that's 2 miles and I know an angle, and this happens to be a right angle like it was before, we're working with the same triangle, just with different vectors on it. So I know a side, I know an angle, I can use SOHCAHTOA again. So here's my angle, 37 degrees. And this would be considered my adjacent, my hypotenuse, and my opposite. So this is opposite of the angle. Hypotenuse is always across from the 90 degrees. So if I have my adjacent and I'm trying to solve for this distance, I want to know exactly how far he traveled. So let's just quickly take a look at that. Oh, my markings here. We know that he went 5 miles per hour along here. So what is that distance? That's what we're trying to figure out. Okay, so we have our triangle. Just redraw it here. I know that this is 37 degrees. I know that there's a 2 here, and I can now solve for the hypotenuse. The distance of the hypotenuse. So this is a distance triangle. So I have adjacent and hypotenuse, so I'm going to go with ka. So cosine of 37 degrees is equal to adjacent over hypotenuse. Now we need to solve for that h. So the algebra there, in case it's been a while, it looks like this. So we multiply this guy up, equals 2, then divide by cos 37. Okay. Once you've done that, you should get, so if you do that, then you should get about 2.6. Okay, so 2.6 miles. All right, so this is a distance triangle, and the hypotenuse is 2.6 miles. So that's the distance that he travels. Okay, so he doesn't actually travel this 2. That doesn't happen because it gets pushed off course. He actually travels this 2.6 along this route here because of the current. So how long does it take him to cross? Well, we know that he traveled a distance of, so distance, actually I should probably use proper notation, v equals distance or displacement divided by time. I know the velocity. Our velocity along that stretch was right here, 5 mph, or miles per hour. So I know my velocity, 5 miles per hour, equals the distance, we just calculated to be 2.6 miles, divided by time. So this will give us our time in hours. To solve for this, you end up with 5t equals 2.6. Divide by 5 to isolate the t. And then t is going to equal, sorry, just using my calculator here, about 0.5 or 0.52. Now what units is that in? Well, our velocity was miles per hour. Our distance was miles. So our time then, so the miles will cross out and you'll end up with hours. So this is an hour. So it took him a half hour or 30 minutes. Okay. So that's how long it took him. So we used basically the resultant velocity, the distance of the resultant, and then found the time. Lastly, the distance he lands downstream from his starting point. So again, this is our same triangle. Knowing what we know about it, 37 degrees. Now think about it. Are we going to put velocities here or distances? We're looking for a distance. So let's put our distances on here. We know that this is 2. We know that this was 2.6. That's what we calculated previously. So these are all in miles. Okay. And the distance that he lands downstream from his starting point. So his starting point is here. He wanted to get here, but he lands over here. So what we're going to look for is this distance there. Lots of different options here. You could use Pythagorean theorem. You could use SOHCAHTOA again, because of course this is a right triangle. You have a bunch of different options here. So, I don't know, I guess we could do Pythagorean. So if we do Pythagorean, it's 2.6 squared is equal to 2 squared plus c squared, or b squared rather. Okay. So then you're going to calculate that, and you'll end up with b squared is equal to 1.66 miles. So this distance here is 1.66 miles, or you could say he overshot the point he wanted to be at by 1.66 miles. Okay. So that's our boy rowing across the stream problem. I will post another video about a similar problem so you can see it from a different angle, maybe asking different questions.